Very good morning to one and all. This is Dr. Gurusharan Kaur from SIRT Bhopal, Department of Applied Sciences. Student, today my topic of lecture is Maclaurin's theorem, which is one of the most important and common theorem to expand the function. The statement of this theorem is if f of x be a function of a variable x such that it can be expanded in ascending power of x and this expansion be differentiable any number of times, then f of x is equals to f0 plus x upon factorial 1 f dash 0 plus x square upon factorial 2 f double dash 0 plus x cubed by factorial 3 f triple dash 0 plus x to the power 4 upon factorial 4 f4 time dash of 0 is equals plus dash dash dash. This series is an infinite series and this term goes to a infinite times. Proof. Let us consider polynomial expression which is f of x is equals to a0 plus a1x plus a2x square plus a3x cube plus a4 x to the power 4 where a0, a1, a2 all are constant. Put x is equals to 0, then we get f of 0 is equals to a0, or this implies that a0 is equals to f of 0. On successive differential, f dash x is equals to a1 plus twice of a2 x plus thrice of a3 x squared plus 4 of a4 x to the power 3 and so on. On putting x is equals to 0 in the same equation, f dash 0 is equals to a1. This implies that a1 is equals to f dash 0. F double dash 0 is equals to twice a0 plus 6a3x plus 12a4x squared plus dash dash dash. On putting x is equals to 0, we get f double dash 0 is equals to twice of a2, or this implies that a2 is equals to 1 upon factorial to f double dash 0. F again we differentiating, we get f triple dash x is equals to 6 of a3 plus 24 a4x plus dash dash. So f triple dash 0 is equals to 6 of a3, or we can say that a3 is equals to 1 upon factorial 3 f triple dash of 0. Similarly, on generalizing, we find a5 is equals to 1 upon factorial 5 f 5 time derivative 0 and dash dash an upon an is equals to 1 upon factorial n f and dash 0. Finally, we substitute the values of a0, a1, a2 in a given equation number 1. We obtain fx is equals to f0 plus x f dash 0 plus x square upon factorial 2 f double dash 0 plus x cube factorial 3 f triple dash 0 and so on, which is a required Maclaurin series expansion, and this series is an infinite series. For example, if f of x is equals to sin x, expand this function which is equals to sin x with the help of Maclaurin's theorem. Students, we have a function of x is equals to sin x. Okay. On putting x is equals to 0, we get f of 0 and which is equals to f sin 0 is equals to, we know that the value of sin 0 is equals to 0. F dash x, the derivative of sin x, we know that cos of x, on putting x is equals to 0, we get f dash 0 is equals to cos 0 and the value of cos 0 is equals to 1. On again derivative with respect to x, we get f double dash of x is equals to minus of sin x f double dash of 0 is equals to 0. And if again we derivative and we substitute x is equals to 0, we get f triple dash 0, which is equals to minus of 1. Fx is equals to f of 0 plus x f dash 0 plus x to the power 2 upon factorial 2 f dash 0 plus x to the power 3 upon factorial 3 f triple dash 0 plus so on. We get the result of, or we can say that the series of sin x, which is equals to x minus x cube upon factorial 3 plus x to the power 5 upon factorial 5 minus x to the power 7 upon factorial 7, and so on up to infinite terms.